Welcome to solverfy.
So in this problem, we're given three pipes, A, B, and C. We have a cable that goes around these three pipes. We have a 50-pound weight on pipe A and a weight W on pipe C. We're given the static coefficient of friction to be 0.25 and the kinetic coefficient to be 0.2. And we're asked for the largest weight W when A is rotated counterclockwise and the largest weight W when C is rotated clockwise. So let's break this diagram down into the three free body diagrams with the three pipes. So we have pipe A over here with the 50-pound weight, the cable coming out from here. We're going to call this TA. We have the cable making an angle of 90 degrees or pi over 2 radians. And since pipe A is moving counterclockwise, we're going to have TA to be the larger weight. And we're going to use the static coefficient of friction here. Now pipe B is the second pipe. So we have the cable from both of these directions. We're going to call this TA and TB. We have an angle of 180 degrees or pi radians. For pipe B, TA is the larger weight because we're moving the 50-pound weight. And we're going to use the kinetic coefficient of friction for pipe B because the cable is moving, but the pipe is stationary. Now we have pipe C. We have the cable coming down this way with W. We have the tension TB. That's the larger tension because the weight W is getting lifted. We have an angle of 90 degrees or pi over 2 or a quarter of a turn. And we're going to use the kinetic coefficient of friction because pipe C is stationary while the cable is moving. So we have our three equations for impending slip right here. So the first equation is TA 50 equals to E to the angle times static coefficient. So TA is 74.05 pounds. To get TB, we have TA, which is the larger weight, over TB is equals to E to the angle times the kinetic coefficient. So TB is 39.5 pounds. To get our weight W, since W is getting lifted, 39.5 is the higher weight. And since the pipe is stationary, but the cable is moving, we use the kinetic coefficient of friction. So we get W to be 28.9 pounds. And this is our answer to part A. So for part B, we have things slightly different here. So we're given in part B that C is rotating clockwise. So let's make some adjustments to our free body diagram. So since C is rotating clockwise, the tension is going to be on the weight W. So the weight W is actually the higher weight in part B. And since the pipe is moving, we're going to use the static coefficient of friction for part B. Now, for pipe B, since pipe B is stationary, we're going to use the kinetic coefficient of friction because pipe B is stationary and the cable is moving. And since the 50-pound weight is being lifted, we still have TA being the higher weight. Now for pipe A, since pipe A is stationary, but the cable is moving, we're going to use the kinetic coefficient of friction. And since the cable is moving towards the 50-pound direction, that's going to be our larger weight. So we made some changes to part B where we're using 50 pounds and the kinetic coefficient of friction for pipe A, TA as the higher weight, and the kinetic coefficient of friction for part B, and W as the higher weight and the static coefficient of friction for pipe C. So let's go ahead and solve our impending slip equations to get our value for W for part B. So for part B, we take 50, which is our higher weight, for TA, to be E to the kinetic coefficient of friction times pi over 2, and we get TA to be 36.52 pounds. For pipe B, we have TA being the higher weight divided by TB to be equals to E times the kinetic coefficient of friction times pi. So TB is 19.48 pounds. And for pipe C, we have W being the higher weight since it's the point of tension divided by 19.48 to be equals to E to the static coefficient of friction times pi over 2. And so W is 28.9 pounds. And that's our answer to part B.